Hello guys, today we're gonna look on pipeline, on how to export crowd agents animation from Houdini and import it to Unreal Engine and apply on CitySamplCrowd characters. But first a little preamble. Uh, yeah, the idea of this tutorial came when I was doing a project for Punisher's 3D challenge. In August, Clint, but not Eastwood, announced a new 3D challenge with a parkour animation. I've decided to participate and, as always, messed up a lot. So this is the preamble. And also I want to say that this is a bit new format for me. I didn't write any script, just some notes, not to forget anything. And yeah, I guess let's start. First of all, about the Punisher challenge. I dig a lot into some technical stuff and completely messed up with the creative part and the look dev part, so I render looks awful. And here it is. But yeah, the main point of this is the approach that I've discovered through this challenge. I've decided to go on the zombie theme. I thought that I want to import some crowds from Houdini to Unreal. I found a pretty cool tutorial from Thomas Christensen. He had a setup with top network that exports crowd agents separately. The main con of that is that he was exporting with meshes and imported a lot of not needed stuff in the Unreal, a lot of skeletal meshes with animations. I thought that it would be cool to import just animations without any mesh. So you have just, for example, 50 animation assets with only skeleton and animation data. So I dig into this topic and found a suitable pipeline. So let's begin. We have a completely free CitySamplCrowds pack on the Unreal Marketplace. All of the stuff is already pre-made, so you just add it to a project and you have all blueprints and stuff and so on and so on. Main point of this is that you have a pre-made blueprint with the randomized meshes, so all of your crowd characters would have different clothing, hairstyles, and so on and so on. So this is cool. I've made a little render for this tutorial and it looks like this. Nothing too fancy, just to show a pipeline and not on the blank scene, but with some environment instead. I didn't spend quite a lot of time on the rendering and so on. I'll just show a walkthrough on this project and then I guess we'll set up a little scene to have some practice. Let's start with exporting the needed stuff from Unreal and then we'll jump into Houdini. First of all, we need to add the CitySamplCrowds to our project that I already did. And this is the folder with the stuff. First of all, we have a pre-made blueprint that randomizes everything on our character. For example, we can use different body shapes, different outfits, different materials, and so on and so on. This is cool. This is what we need. So, the export stage. I've used Mixamo animations for my project. From Mixamo we need any type of bot, Y bot or X bot, doesn't really matter, in the T-pose with the skin, and then any type of animation without the skin. I've set 24 frames per second because my crowd sim in Houdini is 24 too, but you can go with any FPS you want. So we have T-pose and needed animations on disk, and we importing T-pose straight to Unreal with the standard import settings, and then importing all the animations without a mesh, without a skeletal mesh. When you have T-pose whiteboard imported, and when you try to import an animation, you just need to pick a skeleton that is already in engine, and the animation will show up and work perfectly. Okay, the next stage is to retarget our animations onto our CitySample Metahumans. Just right click on the animation, retarget animations, select the target skeletal mesh. For my case it will be F-tall, narrow weight, body. And it looks like this. First click export retarget assets. What this does is creates two IK rigs for Metahuman skeleton and for Mixamo skeleton and the retargeter itself. The next stage is to set up the retargeter itself. All I did is reduce the rotation alpha on the head bone to 0, and then we go to the asset browser and select needed animations and click export. So we have retargeted animations for two skeletons: man tall, narrow weight, and woman tall, narrow weight. The next stage is to export them to disk. The way I did it is shift click all of them, asset actions, bulk, export. Settings look like this. The latest version of FBX exporter. This is ticked off, and we need export preview mesh, and that's all. Export all. Once we have all the animations exported, we need to export some skeletal meshes for the collision purpose and so on. Just select the CitySamplCrowd character and find the folder with skeletal meshes. From here we need mtol base, any of the top part, any of the bottom part, and any of the shoes part. And we need to do this for the woman and for the man characters. We end up with folders that looking like this. We have our face mesh, body mesh, and so on and so on for men and for woman. The export part is done, and we're going straight into Houdini. Okay, the next step is to import all of the stuff into Houdini and set up our agents. Woman agent and man agent looks pretty the same, and we'll look on the woman first. First of all, I'm creating an agent node and importing the base skeleton, and it looks like this. If you press W in viewport, you'll see the skeleton itself. Also, we are setting the agent name, creating locomotion for the specific bone. In my case it is pelvis. The next step is to get all our skeletal meshes and merge them. I'm importing body, top, bottom, feet, and the face mesh, and setting up all in the agent layer. So we have a layer name and the shape itself that comes from the merge node. When this is done, we're going to set up all our clips. For example, I have several running animations and a couple of flips. This is done with an FBX animation import node. Just select the needed FBX, give it a name that we'll use in the crowd sim. Then I'm deleting all attributes except this for position name, transforms, and clip info. And then I'm wiring it into a motion clip and just click on the freeze button. I found that this significantly speeds up the process. We will have an agent definition cache, but for the working state this speeds up a bit. Then the standard agent setup thing is setting up the collisions. Quite funny thing with this stage is that we have already pre-built physics asset in Unreal with correct collision meshes, but we can't export it without some coding. So I've set up it by hand and just made a preset from this node so that I can quickly apply it on the other agent. Then we're configuring joins. Also, I made a preset. I wouldn't dive into this process. There's a lot of tutorials on the YouTube, so you can just watch one of them. Then we're caching our agent to disk, and after that I'm just setting current layers to see something in a viewport. An agent prep node for the footlocking to the terrain, and I'm setting some bones and creating a chop node with all of the animations. And this is it. This is our agent setup stage. For the man, pretty the same process. One and only issue that I would like to show you. I also have the normal Metahuman, and I exported all the stuff, and the issue is this. When we importing body and face mesh and merging it, we have a seam between those two meshes, and if we fuse it, it's okay. If we look on the weights, bone capture, let's set up these to capture weights. This is how the weighting on the face mesh looks, and this is how it looks on the body. And after merging, it looks kinda okay, but when we try to bone deform it, we have completely messed up Metahuman. And I made an HDA that partly fixes this issue. I'm just deleting all the weights and then bone capture lines the body mesh and transferring the stuff on the face mesh. I'll upload it somewhere so you can download and use it. All we have here is a face mesh with the corrected weights. It isn't 100% accurate, but for my case it works okay. We have the collisions, and we can export this to Marvelous and sew some cloth and so on and so on. So for my purpose it works okay. Maybe I'll investigate this topic in future and come up with slightly better results, but for now it's okay. As for NHDA, we have here some import stuff, so we are importing the body, the face mesh, and if we want to preview on some animation clip, the animation. And here we need to select the material from Unreal that is assigned to a head. It can be called something like head synthesized or face mesh. Also we have the preview output. Just create a null and wire it into the blue one, and we can preview a face mesh with the weights or merged with the body, or we can preview an animation. For the first output, we have an extra option, export with body. This is for just exporting the crowd agent with the full mesh. But in my case, I've turned it off. After this HDA, looks like it's pretty okay. And also you have another option to have less nodes on your graph. Just tick the export with body and you'll have one node less. Okay, let's go on. After we've set up all our agents, we need to have some crowd. I'm importing my agents, then some modifications on the clips, then I'm merging all of them and wiring it to the crowd source. I'm using some points that I scattered on the landscape from Unreal, and this is it for the crowd setup. I also have some stuff down here for just for my scene. Okay, let's go to the .NET. Looks like this. I have some static objects for collision, the crowd object, the crowd setup, and nothing too fancy here. And we have some crowd states with all our animations. I have 2 states, running and flipping, and the ragdoll state. It took me some time to understand this stuff, and the main thing I came up with is that we don't need to have the specific name of our animation. Instead of that, we can set this in the crowd source. Just go to randomize and set up your state namings here. You can have different amount of that. I have 2, so I just created running and flipping, and set flipping for the initial state to 0. You just create crowd state and give it a name that you've set up earlier in the crowd state. I set the random distribution, men run and women run, so I've uploaded all my run clips here. All of this is locomotive, so I set the locomotion here. For the flipping, the same process for men and for women animations. Then I have some crowd transition from running to flipping, so you can go from run to a flip state and vice versa. Also, I have a agent lookat node that is set on my animated sphere, and couple steer forces for avoiding obstacle and following my aim animated sphere. In the crowd solver, nothing too fancy again. Enabled lookat for only running state and foot locking. This is all, I guess. The next step is to export our crowd simulation to Unreal Engine. As I said earlier, I found this on the Thomas Christensen YouTube channel, the wedging setup for the topnet. I've made my own HDA from that. First of all, we import fields, then we're caching it to disk, and then I'm just splitting my men and women agents into separate streams. We have 40 of men agents and 40 of women. Okay. So inside the HDA, setting up the topnet with the wedge and the rock fetch. Then we're just splitting all of them into separate agents to cache only one animation per FBX. Here is the most important part of this HDA. I'm just zeroing out the position of the root bone so that we have the proper root motion animation inside of one read. Then I'm deleting the unnecessary bone. For this agent, this would be this one, F tall narrow weight base, but it may be called narrow weight body or something like this. We're creating a group and just deleting some cleanup, and yeah. So what do we have here? Setting up the wedge name for the woman animations woman and for the man, and then 2 states, the wedge node cook and the rock fetch cook. The wedge node cooks just the separate agents, and if we select the rock fetch and then cook, it will start the rendering process. You need to cook wedge node first, and when you are ready to export it, animations, you'll have to select the rock fetch node and press cook. Also, we're setting up the save to disk folder, and also we have a need geometry button. Straight out of the box, this HDA exports only the animation data with a skeleton with no mesh, and if you click this one, you'll export the mesh to 2 buttons here. Check fetch status. So if we, for example, look at this node, dirty wall, then cook topnet and check our status, you see it's cooking, and now it is cooked. And also we have an open test graph table button so that you can check all the states in a separate window. Export part is finished. We have all of our agents for the men and for the women separately rendered to disk. This is just animated skeleton without any mesh. The next step is to import back it to Unreal Engine. I have a separate folder, and all my animations are here and working pretty good. For this to work inside of Unreal, I made a blueprint that is called BP Agent Spawner, and it works like this. You just place it into a scene, then set up the path to a folder where all our animations stored. This one, make sure that you have slash before game. Just Control C and Control V it here, and also you can set the load here. For example, you need the background characters that are far from camera. You can set the load to 5 and it will reduce the cooking. So if we hit simulate, nothing will happen. And it is because of you have two options here, like spawn agents on begin play or trigger a custom event. So if we hit compile and check now, all of our agents are spawned. Okay, cool. Let's look on the scene that I've set up. If we'll scrub the timeline, we'll see everything except of our agents. Why is this? It is because we're spawning all of our agents by this trigger. So you see I have a spawn extra function here, and if we look at our agent spawner, we have a custom event that is triggered by our sequencer here. But if we'll connect the begin play and just disconnect this for a sec and hit simulate, all of our agents are here. I've done this trigger to work a bit more efficient, so it looks like this. If you hit play and then start your timeline, custom event triggers, and we have our crowd running. But you can go with the event begin scenario. Let's imagine that we already exported all of the animations and set up our agents. So we'll just create some simulation, quick sim. Yeah, let's do this. Crowd setup. I'll grab my women agent. Object merge it here. This one is done. Let's do this for the main one. Cool. Merge. Then we need some crowdsource. Straight out of the box, we have only women agents. So we need to randomize agent primitive. And for this I'll select a woman and add some men. We can tweak some weighting parameters here. Also, we need to create two states, like run, for example, and flip. And we don't want our agents flipping at the start of the simulation, so we'll set this to 0. From here, we'll unhide our shelf tools and go to crowds, then hit simulate, select our crowd object, and we need to have some weighting on the second state to show it up on this simulation setup. Let's redo this quick. Yeah, we have our flip and run states. We'll also click the ragdoll one and click accept. From here we can return to our crowd source and set this one to 0. So we have crowd simulation.network set up for us. And if we go here, we can see our flip, run, and ragdoll states. We'll set the random distribution, and this is our flip state. Let's add 4 of them and select all of our flip animations for man agent and for woman agent 2. And let's set this to locomotive. Yeah, let's do quick the same for the running state. We need 8 of them, and also add some randomization for the clips. Let hit simulate and see what happens. They are running. Let's do some foot locking. Let's go with a grid. Out landscape. And let's copy this. Enable terrain projection. And the subpath is our out landscape. Let's static object just to see what we are dealing with. The same out landscape. Let's check it. Yeah, it works. Let's see how it works in the simulation. Add some transitions. Let's check this one. And yeah, we have our agents running, flipping. This box is triggering ragdolls, but because of some penetrations, they look a bit strange, but we'll keep it like this. Let's imagine that this simulation is super duper cool, and we're happy with that. Let's go to the Pio import. Let's cache it to, I don't know, 200 frames. And now we need to export all of our animations. For this one I'll split women and men agents. For this, at name equals prefix men underscore everything name. Okay, so yeah, we have our men agents and our women agents. Now we need our HDA. It is called crowd export to Unreal, and here we need to set up the man wedge name. Let's cook the wedge node. We have all our animations. Let's choose the folder. You don't need to specify file extension, just select the folder. I don't know what's happening, but it looks like it's happening only in this specific project. Maybe some issue with the dependencies, I don't know, but I checked on the another project, it works like it should. So let's cook our wedge node. If we check the status, it is cooked. If we check the task graph table, it is cooked. And if we select the rope fetch node and check the status, it will show that all of those are failed. But we'll do the same thing, but with one correction. It will work okay. Okay, this is totally strange. But if we'll check our folder, all animations are here. And if we'll check status, it is failed. But if we dirty and cook again, the status will be cooked. I don't know, this is happening only in this project. Okay, let's delete this one. Let's quickly create another one for the women stream. I'll double check in another project. It should work. I don't know what's the deal. Dirty all, cook, save, check, cooked. Okay, let's check here to text movement. We have all our animations. Okay, while Unreal is loading, I'll do another thing. We'll export our ground to have it in Unreal. Rope FBX, convert units, let's set up folder. Okay, save to disk. Let's import our ground, aka landscape. Let's drop it here, 0 out. Let's delete our floor, and we have everything in place. Let's create another folder for our animations, and inside here we'll create 2 new folders: men animes, women animes. I'll grab all of those, grab them here, and here we need to select the right skeleton. And I know that for CitySamplCrowd characters we need to select this one, SK base. Is you see the path game CitySamplCrowd character shared rig, and this is the needed one. We'll select this and everything by default. Let's import. They are imported. Let's check. We have our skeleton running. Let's check on the agent spawner. We'll just throw it somewhere in the scene, then zero out the location, copy our path to a folder with animations. I'll set this to run on the event begin play. And let's test, simulate. Yep, our agent's in place. Maybe I'll do some switcher here. Yeah, definitely.
A few moments later.
Okay, I'm back. I've added a checkbox if you want to use main logic by trigger or on the event begin play. So if it is turned off, will spawn agents triggered in sequencer. If it is ticked on, it will spawn on the begin play. Let's do the rest for the women. Paste it here and let's check why the begin play. Everything in place. Running, flipping, dying, all the different meshes, different hairstyles, and so on and so on. Pretty cool. And that's it for the main part. I also have some tips for inside Unreal stuff. First one is how to enable Tesselation by default for the new projects created. You need to find the base engine.ini file. It is stored on the C, program files, epic, UE5 and version, engine config. Open it with a notepad and search here for renderer. Not the slate one, but the first one. Yeah, this one, script engine renderer settings. And paste these two lines here. Nanite allow tessellation equals 1. Nanite tessellation equals 1. Then just save it and done. You have tessellation enabled by default, so even if you create a new project, tessellation will be on. The second one is for the frame rate, importing all the crowd animations into Unreal. I saw that it jitters a lot. Maybe I can recreate it. Frame rate, let me see. Yeah, if you see some jittering happening, here's not a lot of agents, but if there's more than 50, I guess it would be more noticeable. So to fix this jittering problem, you need to go to the project settings, search for frame rate, and tick use fixed frame rate, and set the desired frame rate. I simulated in 24 FPS, so I am setting here 24. And also, little quick fix, I have a geometry cache here. I exported my wiggly moving sphere stuff from Houdini via Alembic, and so I'm setting it up here with the geometry cache. It was playing a bit too fast than it should, so...
Am I a joke to you?
So the way I fixed it is to go to the sequencer's frame rate settings, and here under clock source set it to tick. By default it is set to platform, and if you set it to tick, it works at the desired speed. The third tip I'll show you in my Kinetic Crash project for the Punishers challenge. And here is the situation. All animations in this pipeline work from world 0 coordinates. For example, you have your animated camera somewhere around world 0 coordinates, and you have your crowd agent spawned, for example, somewhere here. When we're triggering event begin play, all of your agents will spawn at the 0 coordinates. You'll see them for one frame. In this case, we don't want that. So what I found is you can place your BP agent spawner 500 units higher than 0, and import your animations 500 units lower than 0, so that when you hit the play button, all of the agents spawn somewhere higher, but on the right spot, like in the crowd simulation, and you won't see them in camera. Okay, moving on. The last quick tip is console variables collection. It's a good practice to create a console variable collection and store it somewhere on your disk, and when you just creating a project, you can go to plugins tab, search for variables, and enable console variables editor. After restarting your Unreal, without this plugin enabled, this file couldn't be opened. You can add all of the most used console variables here and just save as a preset. And you can access this anytime. What you can do with this? For example, you have multiple sequencers. You need different console variables for different sequencers. You can save different collections and just add them to sequencer here and select the needed one from the list. Or you can add those collections here in the movie render queue. Just add the console variables from the plus settings and select your preset. And maybe the last thought about your namings. For example, when you retargeting animations, it's a good practice to set some prefixes. For example, retargeted in the front and man at the end, so that you don't mess up with the namings. When you importing animations, just create proper folders with man prefix, woman prefix, and all of your animations will look readable and useful. In my case, I'm using man and woman. You can create different namings, but in my case, I found that this one is more readable. I think that's it for this tutorial. I hope you learned something new and it will be helpful in your creative life. Okay, see ya!